Okay, we have to look at mass, moments, and center of mass. Um, and I'm assuming those of you who have been through physics have talked about mass before. On Earth, we associate mass as a weight because of Earth's gravitational pull. Um, Technically, the definition of mass is a measure of body's resistance to change in motion. But because of Earth's gravitational pull, we usually just associate mass with weight. Force, what we've been looking at, is mass times acceleration. I'm trying to think what else you're going to need to know. So then mass would be um, force divided by acceleration. These are probably all formulas that you've used in physics. Um, what we are going to look at today really doesn't involve any calculus. We're going to look at one-dimensional and two-dimensional centers of mass. So center of mass, oops, not sure what happened there. Center of mass and one-dimensional. In this one, I know you've done problems like this before. The easiest one-dimensional center of mass that I can think of is the teeter-totter or seesaw problem, where you have this here. So about this point, and I'm sure you talked about fulcrum, so we're not really getting into that too much. We're getting into if I put a 20 kilogram weight here and a, whoops, not sure what's going on there. Let's just do this. And a 30 kilogram weight here, and let's say that this one is 3 meters from this point right here. If I want this to be balanced, I would need to know the distance from this point out here where I want to set that 20 kilogram weight. And that is just a direct variation. It's just we call that a moment, the moment about a point. So the moment is equal to the mass times x, where x is a distance from that point, or the fulcrum if you're talking about a teeter-totter or seesaw problem. So a moment is, I don't know why my pen keeps doing that, I apologize. The moment is the mass times x, which is the distance from the point. If it's one-dimensional, we're centered around a point. So if I take 30 kilograms times 3 meters and set that equal to 20 kilograms times such and such a meters, whatever I'm looking for there, we're just calling it x, then I can figure out the distance I would want this 20 kilogram weight to be, and it looks like it'd be 90 over 20 or 4.5. So that is one dimensional. You've done some one dimensionals before. If you, the ones that you're going to look at in just terms of algebra and calculus is you're going to be centered about the origin. And so if we're going to look, we call that a moment about the origin. And we m sub o is how that's written. How you find that moment about the origin is you take your first mass, the weight or the mass times its distance from the origin, so x1, and then you'd take your second mass times its distance from the origin, and you would keep doing that with how many ever objects that you had. So your last one would be, we'll just call it the mass of the nth object times x to the n, so its distance from the origin. Um, that's the moment about the origin. The center of mass itself, to find the center of mass, is we use this x bar for center of mass, is the moment about the origin divided by the total mass. So this little m down here is the total mass. So all of your objects added together. Alright, let's just try one real quickly. Let's say that I have m1 equals 4 and x1 equals negative 1 and m2 equals 8 and x2 equals 4 and m3 equals 4 and x3 equals 1. How I picture this is on just like a number line from pre-algebra basically. So here's 0, 1, 2, 3, 4, and negative 1. So at negative 1, when x is negative 1, there's a 4-pound mass, or 4, whatever it's in. I didn't make it pounds or kilograms, whatever it's in. And at positive 1, there's another 4-pound. And at positive 4, there's an 8. So let's start by finding the moment about the origin. So I'd have 4 times negative 1 plus 8 times 4 plus 4 times 1, and I'd add those up and I'd get 32, which would make sense that these would zero out, because if I just had those two there, then that would be at 0. So the moment is 32. So then the center of mass, or the x bar, is going to be 32 divided by the total mass. Well, 4 plus 4 plus 8 is 16. So it would be 2. And that's pretty much all you have to do with one-dimensional. Now let's look at two-dimensional. So that just means we're going to be on a coordinate plane then. So instead of having just a number line, when you're doing two-dimensional, you actually will have the coordinate plane. So I'm just going to put that there for a second. What you need to remember with your coordinate plane problems is that you have a moment about the y-axis and you have a moment about the x-axis. Okay, so this is moment about the y, and then this one would be about the x. So m sub y and m sub x. My moment about the y-axis is equal to m1 times x1 plus m2 times x2, and it keeps going with how many ever that you have. So we'll say mn times xn. And so the moment about the y-axis involves x, because the distance from the y-axis to any point that I would put out here, so the distance, let's say if I have a point here, the distance from the y-axis to there is an x value, so that's why I use x's. So that means the moment about the x-axis would be the mass of the first object times its distance from the y-axis, so m1 y1 plus m sub 2 y sub 2, and it keeps going how many ever terms that you end up with, mn y sub n. So when you get your center of mass, because it's two-dimensional, before we just had x bar, well actually we're going to have an ordered pair. So with two-dimensional, your center of mass will be an ordered pair. It'll be something and something. So your center of mass for your x value is going to be the moment with y, with respect to y, over the mass. And your y center of mass is going to be the moment with respect to the x-axis over the mass, the total mass. And m again is just the total mass. So let's try, let's say that at negative 1, 4, I have a mass of 6. And at 4, negative 3, I have a mass of 2. And at 2, 1, I have a mass of 4. And I'm just going to do 3 to show you this is not difficult. So I would just go to negative 1, 4, and I just like to draw, there's my 6 that I'm going to have there. And at 4, negative 3, I have a mass of 2. And at 2, 1, I have a mass of 4. So what I do is I find my total mass. I guess I could do that first. So that's 8 plus 4 is 12. And then I find my moment with y. So it would be my x value, so negative 1 times 6, or 6 times negative 1, so the mass times the x, plus 2 times 4, plus 4 times 2. So I get negative 6 plus 8, which is 2, plus another 8, which would give me 10. And then the moment about the x-axis, I'm going to take 6 times 4 plus 2 times negative 3 plus 4 times 1. And then you'd get 24 minus 6 plus 4, 24 minus 6, 18, 22. Alright, so my center about the x, So my x coordinate is going to be 10 over 12, or 5, 6. And my y, center about my y coordinate is going to be 22 over 12, or 11 over 6. You'll have to excuse my children. They're very loud. So this ordered pair, 5, 6 and 11, 6. So 5, 6 and 11, 6, like right about here. This would be your center of mass for those. And that's it. Have a great day.